that's just real.
Okay, boys and girls, we are moving into our next unit, which is improper fractions and mixed numbers. If you did not watch the Edpuzzle video from yesterday, I highly suggest that you watch that. It breaks it down in very small steps with pictures and models, and the guy that is narrating the video has a pretty cool accent, in my opinion. So make sure you watch that. And that will give you some practice on turning improper fractions into mixed numbers and vice versa. Okay, so we are going to look at this model right here that I just drew. So my lines are not perfectly straight, and that's okay. And this model is showing what as a mixed number? What would be the mixed number? Well, what is a mixed number to begin with, I should say? What is a mixed number? Anyone?
Mixed number is when you take fractions, but you have to like shade it in like whole ones.
Yeah.
And then leave a fraction.
Yes. So a mixed number has both a whole number and a fractional part. Okay. So in this mixed number, we have 3 whole circles shaded in, and the fractional part is this guy right here. And so that fraction represents what? 1/4. Okay, so our mixed number for this model is 3 whole and 1/4, and we would just say 3 and 1/4. Okay, now if I were to break apart all of those pieces, so imagine those circles just kind of separating a little bit, and I have fourths in that model. How many fourths are shaded? We can count them, and when I count them, I'm gonna put little dots on them, so we can count them together. We could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 fourths. Okay, so both of those things represent that model. We have our mixed number, which is 3 and 1/4. And then what do we call this guy right here? That's called an improper fraction. And why is it called an improper fraction?
Because a fraction has the smaller number on top of it, and the proper one has the bigger number.
Okay, so an improper fraction has a larger numerator than the denominator. So improper means that our numerator, I'm not going to be able to fit this on there, numerator. That means our numerator is larger than our denominator. Okay, so that means that I have enough fourths to make at least 1 whole. In this case, I have enough fourths to make 3 whole. Okay, so I am going to not go to the next slide yet. I want to insert another slide first. Here we go. Okay, so we're going to stick with these two values that I wrote, this 3 and 1/4 and 13 fourths, because they both represent the same amount. Okay, so how can I go from a mixed number to this improper fraction? How can I go from this mixed number to this improper fraction? Well, in the video yesterday, from the Edpuzzle video that I posted yesterday, he goes into detail about breaking it down into the going from the mixed number into the improper fraction. So basically, if we are going from this to the improper fraction, this mixed number is telling us that I have 3 whole things and a fourth of another. Okay, now if you remember, your denominator which is the 4, tells you the size of pieces. Okay. So if we have fourths, then that's what we are talking about. We are talking about pieces that look like this. Okay. That's a fourth. All right. So if I have 3, if you imagine having 3 whole pizzas and they are all cut into 4 slices, okay, that means you have a pizza and another pizza and another pizza. And if they are all cut into 4 slices like this, how many slices do you have? 4, 8, 12, right? Okay, so when you're going from a mixed number to an improper fraction, you're going to take that 4 or that denominator and you are going to, let me get rid of some of this junk I got on here. You are going to multiply that times the whole number, okay? So that's telling you that I have 3 whole things and they are all cut into fourths, or they have fourths as their piece size. Okay. So this right here represents this 4 times 3. This 4 times 3 right here. So that's giving us the 12. 4, 8, 12. Okay. Then you have 1/4 of another. So this extra piece, oops, this extra piece right here, this 1/4 of another is hanging out here. So we have to add that amount to the 12. So you're taking your denominator and you're saying 4 times 3 is 12. That's getting you those 12 pieces plus 1 more out here. So 12 plus 13. And I know that looks really, really sloppy. So I'm going to erase this. And we are going to do that again. So I've got 3 and 1/4. Okay. So I'm going to take my denominator and I'm going to multiply that by my whole number, which is going to give me 12. Okay. So that is 12 plus 1 more is going to be 13. And that's how I get the 13/4. Okay. So I take my denominator, I multiply it by the whole number, and then I add the numerator. My denominator stays the same. Okay. So how then do I go from 13/4 or my improper fraction back to my mixed number? Well, in the video yesterday, he was talking about this looking like a division problem. So if I have 13/4, whoopsies, I didn't want to do that. 13/4, okay, this means 13 divided by 4. All right. So if I have 13 divided by 4, I could write it like this. All right. And I would say if I had 13 and I wanted to divide it into 4 groups, how many would I be able to put into each group? 3. Okay. So that's my whole number. All right. I could put 3 into each group. And 3 times 4 is 12. And I would have 1 left over, which we would say is our remainder. Okay. The part that I have left over, or this 1 piece that I have left over, is the fractional part of the mixed number. So I have 1/4 left over. So 4 goes into 13 3 whole times, and I have 1 left over. 1 what? 1/4. Okay. Let's do another example. Okay, let's go to this one. All right. Let's talk about the mixed number that this one represents. So how many whole models are shaded? 4. Okay, so that becomes my whole number. Okay. And so 1, 2, 3, 4 whole. And this is the fractional part right here, which is 2/3. Okay, so pretty easy. So I have 4 whole and 2/3 of another. What would be the improper fraction for that? So I can count each individual shaded piece. It is going to be 14/3. Okay, I can count each individual piece. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I could say that's going to be 14/3, which is the improper fraction. How can I use math, or what can I do mathematically to turn this to turn this mixed number into that improper fraction? So if you think about it, all of my models are cut into thirds, right? And I have 4 whole models that are cut into thirds. So I'm going to take that whole number and I'm going to multiply it by my third. So that's going to give me 12, right? I'm taking 1, 2, 3, 4, and I'm multiplying that by 3 because they are each cut into 3 pieces. And so that is going to give me 12 pieces. 3, 6, 9, 12. So 3 times 4 is 12 plus 2 more from the fractional part. So 12 plus these 2 gives me the 14. Okay. So again, if I were to rewrite that like this, I'm taking my denominator, I'm multiplying it times that whole number to make the 12. And then I'm adding 2 more pieces to that to make 14. 14 what? They are all thirds. Okay. So that's how you would do that mathematically. So if we had something that was, let's say 10 and 1/8, I'm not going to want to draw a model of that. It would take me a long time to do. So how can I turn that into an improper fraction? Using math. Remember, I have 10 whole pizzas. I like to use pizza when I'm talking about fractions, and it's my favorite food. So if I had 10 whole pizzas and they were cut into 8 slices each, how many slices is that?
2.
If I had 10 whole pizzas and they were each cut into 8 slices, 80. Yeah, it would. So 8 times 10 is 80 plus 1/8 of that other pizza would give me 81/8. Okay, so I'm going 8 times 10, which is 80, plus 1 more, which is 81, and my denominator of 8 stays the same. Okay, if I wanted to go the opposite way, if I wanted to say 81/8, okay, I can say, well, 8 goes into 81 how many whole times without going over? 10. That's the whole number. Okay, that's going to be 80. 81 minus 80 is 1. I would have 1/8 left over. If you had to write it out like this is what it would look like. So 8 goes into 81, 10 whole times, which is 80. And when you subtract, you end up with 1 remaining. 1 what? 1/8. Okay, now why is this going to be important? Well, let's say we had to add 2 and 5/8 plus 3 and 4/8. What if we had to add those two things? Whenever you're adding mixed numbers, you should always add the fractional parts first. Okay, that's what I always do. So just in case you have to turn an improper fraction into a mixed number. So if I added 5/8 plus 4/8, how many eighths is that? That's 9/8, right? Okay, so I've got 9/8, and 2 plus 3 is 5. So 5 and 9/8 is my answer. But can you leave it like that? No, you can't leave it like that. This is improper, and we don't leave improper fractions improper. So I then have to think about what 9/8 is as a mixed number. Can anybody tell me that? 9/8 as a mixed number. 1 and yep, 1 and 1/8. And so how did you think about that? Like, what was your thought process? So you said, were you thinking, oh, if I have 9/8, I know that 8/8 is going to make a whole, right? So if 8/8 makes one whole and I have 9 of them, then I'm going to have 1 extra eighth. So I'm going to have enough to make one whole plus 1/8 left over. Okay. Or you could just think about it like this. So 9 divided by 8. So 8 goes into 9 one whole time. And 9 minus 8 is 1. So my leftover, this guy is my numerator. Okay. So it would be 1 whole and 1/8. Okay. All right. And then, so then we're still not done. So if 9/8 is, let me erase some of this. This is junking up my screen. So we said that 9/8 is 1 and 1/8. So then my answer is going to end up being what? I had 5 and 9/8. Yep, I transferred 9/8 to 1 and 1/8, but then I had to add that to that 5 whole that I had up here. So my answer is 6 and 1/8. Okay, so sometimes when you're adding mixed numbers or adding fractions, you have enough that it's going to give you an improper fraction. So you have to simplify it into its mixed number. Okay, and then sometimes this is the other reason why we have to know how to turn a mixed number into an improper fraction. Okay, so I'm going to show you another problem that looks like this. And we're going to be getting into this next week. So let's say I have this. Okay, I have a subtraction problem. Okay, so I have 5 and 1/8, and I need to take away 2 and 7/8. All right, but I have a problem right here. This is a problem. If I only have 1/8, can I take away 7 of them? I can't. Okay, I cannot do that. So there's a couple different things that we can do. The first thing that I'm going to show you, the first strategy that I'm going to show you is we are going to change this mixed number right here into an improper fraction. Okay. So if I had 5 and 1/8, what is that going to look like as an improper fraction? So 8 times 5 is 40, and 40 plus 1 more is 41. So that's going to give me 41/8. Okay. So 5 and 1/8 is the same thing as 41/8. And I need to do the same thing down here. So I'm going to take 2 and 7/8 and turn that into an improper fraction as well. So 8 times 2 is 16, and 16 plus another 7 is 23. Okay, now I have plenty of 8s up here that I can take away 23 eighths. I can take away 23 eighths from the 21 or from the 41. So when I do that, 41 minus 23 is, anybody? 41 minus 23 is going to end up being 18 eighths. Okay. And then I have to take this improper fraction and turn that back into a mixed number. So think about how many times 8 can go into 18. 2. Okay. 8, 16. All right. So I have enough 8s to make 2 whole. And how many would I have left over? I would have 2 left over. Okay. And then I would have to simplify that to 1/4. So your answer is 2 and 1/4. Okay. So that's one way of doing that problem. Another way, I'm going to do the same problem. So 5 and 1/8, 5 and 1/8 minus 2 and 7/8. Okay, here's another strategy. Okay, I prefer to do this because I don't think it takes me as long to work out the problem, but that's just my preference. So I have like denominators, so I can subtract. However, I only have 1/8 again. So I can't subtract 7/8 if I only have 1/8. Do you know when we have something like this, like 73 minus 29? And what happens if you don't have enough ones to take away 9? What do you have to do? You need to get more ones, right? And so where do you get more ones? You get more ones from the 10, right? You take a 10 and you trade it in for 10 ones, which you add to the 3 that you already had. So I end up making this 13. Okay. All right. And then I'm able to subtract, right? The same thing can happen if you need to regroup a mixed number. So if I don't have enough 8s right here, where can I get more 8s? I don't have enough 8s here. So where can I get more 8s? I can get more 8s if I take one of my whole numbers and turn it into 8s, right? So how many 8s equals one whole? 8, right? So I'm going to take this 5, all right, and I'm going to take one whole from that, and I'm going to trade it in for 8 eighths, which I need to add to the 1/8 that I had. So again, I'm not making this an 11. I'm not adding 10 eighths to that. That's a no-no. I'm adding 8 eighths to the one that I already had. So that becomes 9 eighths. So now I have, if I look at it up here again, I know this is a lot of writing. This is 4 and 9 eighths, which is in fact the same as 5 and 1/8. Okay. Now I can use my 9 eighths to take away 7 eighths, and that's going to leave me with 2 eighths, and 4 minus 2 is 2. And we would simplify that as 2 and 1/4, which is the same exact answer that we got back here. Okay, so there's 2 different strategies when working with subtracting mixed numbers and things like that. And we will be practicing that next week. So make sure that you catch that Ed puzzle from yesterday. And if you need a refresher, you can go ahead and watch this video as many times as you would like.